Hello folks. Yesterday I thought of a project idea using a microcontroller. Now I'm most familiar with the AVR family of microcontrollers, so I'll be using one of the AVR's 80 tiny microcontroller for this project. But the more I thought about the project, one thing I realized is I didn't have an easy way to debug the program that is running on the controller. So that got me thinking, what are the various ways that you can actually debug a program that you write into a microcontroller? So in this two-part series, we'll look at some of the ways that you can actually debug your program that you write on an AVR microcontroller. Now, mind you, the Arduino also uses an Atmel AVR, but things are slightly different there. The Arduino has a lot of supplemental devices on the board itself that lets you do serial debugging. Well, when I mean serial debugging, it's just writing a few debug statements in your code and watching them using a serial monitor. But when you use a raw Atmel device like just the chip, no peripherals around it, that becomes slightly difficult because you don't have any device that can talk to your PC using over USB. So that's when I thought about how about I go around doing a video about it so that it'll help you guys who are trying to debug and are in the same situation as I am. So let's get on. So this is the hardware that we are going to use today. This is 80 tiny 84 AVR. It has about 512 bytes of RAM. This is a DIP 14 package. This is a USB to TTL converter. All the magic is actually going to happen here. What this does is this will connect to your USB port on your computer and it will present itself as a COM port, wherein you can then just open a console window and talk to this device as if it is any other serial communication device. Now the key thing is this device converts the USB stream into discrete transmit and receive, and you get two discrete transmit and receive pins with a ground +5 and a 3.3 volt output as well. These can be had on eBay for as little as $1 with free shipping. Sure, it takes about 3 weeks to get them, but well, you can't beat the $1 price on these. So I'll be using one of these and we'll be going through the process of testing this once you have set this up on the computer and actually connecting this TTL USB to TTL device to your microcontroller. So let's get back to the software side of business.
Okay, so I've plugged in the device into my USB port and let's see which COM port it has detected it as. And if you look at it, that's the device and that is connected to COM port 5. Alright, so that is all good. Now let's do the next test, which is the loopback test, and see if the device is actually working and responding to the communication.
Okay, so here we are after installing the driver for this device on the computer. Now before doing anything else, we'll first test if this device actually works as expected without even connecting this to the microcontroller, and that way we can eliminate problems before they even arise. So in later stages, if you connect this device to your microcontroller and it stops working, you can straight away eliminate that the device is not a problem because we had already tested this. And then it could either be your microcontroller or some communication between these two. Now, to test this device, what we are going to do is called the loopback test or loopback test. And in that test, what happens is we will just install a loopback. Loopback is nothing but a short or a jumper between the receive and the transmit pin of this device. And I'm just going to put this jumper onto those two pins. Now, what that does is anytime any data that comes out of your PC, which actually is intended for the device, is loop backed onto the receive pin of the device, which can then be read back by the computer and thinking that it actually came from the device. So effectively, by doing this loopback test, you're just testing this device and nothing else. So now we have installed this jumper, and now let's go back to the PC and see if this device passes the test.
So I have the device connected to the USB with the loopback jumper, and let's test it to see if the device actually works. Now here I have the Arduino IDE open. What I'm going to do is select the port the device is detected as, or the device is connected to, which is COM5, and then let me start the serial monitor. And let's try some basic strings. And yes, so the moment I hit enter, or if I click send, the string is actually sent to the device, goes to the TX pin, and via the loopback adapter, loopback jumper that we have, it comes back in through the RX pin and back into the console. It is not, so this is not displaying just the string that I'm typing out here, but it's actually the complete loop that is it's completing via the adapter. And we can verify that by, I'm just going to take out the jumper. There, the jumper is out. Now let's try a string again. Nope, and it disappears. So that meant I'm going to put the jumper back in, and let's try that again. There it is. So the loopback test works. The device is working fine. Now we'll look at how do we connect this device to the AVR to display the debug information.
Alright folks, so after the loopback testing, we know for sure now this is working fine. The TTL to USB device is working fine. Now let's test it with an actual AVR. And what I have here is I've mounted the ATtiny 84 onto a breadboard, and I've connected a USB ASP serial programmer to it using the 6 in-circuit programmer pins that we have, the MOSI, MISO, SCK, and ground and VCC, and reset of course. So that is wired up here. Now we'll just wire up the TTL USB to TTL converter to this AVR and then get back to the PC to look at the programming. So let's get started with this. Let's take off the jumper. Now one thing that I failed to mention earlier was in this debugging scenario, we are not going to have a two-way communication between the PC and the AVR, because that is not something that we really need for debugging. All we need is any code that is spitting out debug statements on the AVR should be visible on the computer. So for now we are just going to look at one-way communication wherein the AVR is going to write something to this device, and then we are going to hook up our serial monitor to this and see that statement on the PC or computer screen. This, however, does not mean that we can send some data back to the AVR. That can be done, but we will keep that for a later tutorial. So for now, it's just a one-way communication from the AVR through the TTL device to the computer. Now to get started, all we need to do is make sure we have common ground. So we connect the ground to the ground of the AVR, and then we need the receive pin connected to one of the port on the AVR. And for now I'm choosing the port B, pin 0, and that is the second pin on the AVR microcontroller. So now we have everything wired up, and let's get back to the computer to see how to program the AVR, or what program to write into the AVR so that we have enabled the debug to this.
Okay, so here we are at the computer, and I've plugged in the USB serial device which is connected to the AVR, and the AVR is also connected to the ICSP programmer, or the USB ASP programmer that we have. Now let's jump into Atmel Studio, and let's create a new library for the USB TTL, or the USB to serial code. Now I say new project, GCC C static library project, because mostly the code that we have is actually just assembly language. So going with the C for now would be a better option. Let's give it a name, saying serial. Okay. And then it'll ask us for the device. Let's look at ATtiny 84. Okay. Alright. Now, if you look at it, it automatically added this USB serial file, but we won't be needing that. So just delete that. And then what we would do is just right click, say add new item, and say USB serial.s, which is the assembler file. And there we have it. Now let's look at the code that we have for this function, and the code is available on GitHub, soft UART, by a gentleman named Ralph. So all we need out of this is just the tx time byte function and not the rx time byte, because we are just going to transmit from the AVR, not receive from the AVR. So what I'm going to do is just copy this. Sorry, we need all of that as well, and paste it into here. Alright, now that's interesting. And to select this vertical columns, all I did is I clicked Alt, press Alt, and then drag. So that will let you select columns, and then just press delete, and it's deleted. Now, right, I think we are missing, so in this code I think we are missing one define, which is the, so we have the UART port, we just need the UART pin. So UART pin, and let's make this pin 0. Your port X, and that is good. Alright, now let's save this. Let's try compiling if this works. Okay, well, that makes sense because we don't have any such. Let's remove that and let's try again. Okay, define. Oh, there it is. Okay, that's the problem. I see that. So let's see which UART port we want. We'll say, so for now we'll use UART port as port B on the AVR. And this will be port B. Let's see if that works now. And yes, we are able to successfully build this. Okay, no errors. Now what we'll do is we have our library created. If you look at the name would be USB Serial dot. And now let's start a sample application, or let's create a sample application that will use this library. So let's now create a sample application which will in which I'll demo how to use this library that we have just created. And then in a new project, this time we would need let's take a C++ executable project, and let's give it some serial debug sample. Same way, device select, we have AVR 80Tiny84. Just select that, and we have it. Right, now we will need most of these things here, so let's keep it here. Now the first thing that you would want to do is we would need to add the library that we have just created. So we'll go browse libraries, and let's go to serial debug simple. We have USB serial, there it is, and USB serial.a, and that is it. Now once you select OK, you would see the live USB serial A in here. Interestingly, well, the function name that we have, so the first thing that we need to do is we need to tell the linker where to find the txtime byte function, and for that what we need to do is we have to define an extern reference. So extern, the return type is void, we have tx timed byte, char is fine. Now we'll see what these two things are, but that's the basic definition. And then in your while loop, all we can do say something like txtime byte, the character, and this is actually the timing. Now let's get into the details of what is the second parameter here. The first parameter is of course the character that you want to print, but the interesting thing is the second character. Now let's jump back a minute to our library that we have. Now in this library it actually takes two parameters. Now if you look at it here, there are two parameters here. One is a delay count, and then there is the actual the transmit byte is in 24, so it's actually interesting. Alright, so it's just using the loopback, so we don't have a variable for the character in itself. But the delay count, now what this is this delay would determine the actual speed at which the AVR will transmit back to the computer, and that will define your baud rate. Now there is a slightly complicated relation between the baud rate and the speed at which AVR is running. So to make it simple, let's do this. This is a simple formula that you can use to calculate the delay timing that we have based on the baud rate and the clock of the AVR. And this is a fixed formula, so you can just copy this formula over and over again, and that should be fine. So now the formula basically goes something like this. So that's the macro that we have defined, and goes as fCPU. fCPU is actually the clock of the AVR that it is currently running at, divided by baud rate, which is the baud rate we define or we set it to run at, and these are all constants that we'll have to define before we actually write anything in the code. Or this is a precompiled. These are precompiled constants, and these cannot change or once we compile. So that is our TX delay. So what we can do is TX delay. That should do it. Now let's just build. Alright, so that makes sense because we haven't defined fCPU nor we have defined baud rate. So now let's just define these two. And let's keep it at 9600. And let's define the CPU clock at 1 megahertz. Right. TX time byte. Did we miss something? Of course we missed this. Now this is a tricky part. Now since this is a C project, what we have done here, if you look at it, we have just said extern void TX time byte. Now if you remember our library project, we actually compiled it as a C project and not a C library and not a C++ library. And that should tell us what it is. It's a AVR C compiler and not a C++ compiler, as you would see here. There you go. So what basically we would need to do is define this as a C extern and not a C++ extern. So we say extern C void, and that should do the trick. And there it is. Fantastic. So now it works fine, and the linker can find the code, and there it is. Let's try uploading this program to the AVR. We get the results that we expected. So I'm going to say tools. Alright. So this is nothing. So if you look at these three, this is nothing special. All I've done is I've integrated the USB ASP into the menus of the Atmel Studio, and that's just convenient. Whenever I want to just program it, I have passed in all the parameters. Show that. And these are the parameters that I passed in. The -C is the USB ASP programmer. It asks for the chip, which chip it is. I've selected the ATmega328, and that's why it's saying ATmega328P. If I select ATtiny, it will be a different chip. And then the uFlash is basically tells it to override the flash memory and write with this file. And this is the file name. So if you look at these, the $projdiff and the $target name, these are macros that are defined by Atmel Studio, and that is it. So here what I do is, let's run the ATtiny84 and let's say okay, and there you go. That has been uploaded to my AVR. Now let's go to Arduino IDE. open our, let's see if we have it connected. No, we don't. So let's connect it to COM5 and let's open the serial monitor. And oops, what we have here? Let's stop auto scrolling. Let's see if this is working fine. Well, what is happening here? Okay, so let's look at our program again. And if you look at it, we have no delay in here. All the program is doing is continuous spamming the TTL interface or the TTL device with the character A. So just to make it a bit sane, let's add a delay in here to see what is happening. Delay.h, and let's add about a 500 milliseconds of delay mess and 500. Alright, now let's try the same thing again. We go tools, go to ADTiny before, and yes, now let's see what we have here. And it is set to 9700 baud, and look at that. That is the same character that we are reading back from the AVR. Fantastic. Now, just writing a character out, well, not so helpful. What we'll do is just add a simple function in here that can spit out strings as well. So let me just stop that. And let's write a function that we can use to output strings directly. That's it. That's all we need to do. And we need to forward reference this. And then what we'll do is let's say tx string word. There we have it. Now let's build this and see if it works as expected. It's built. Now let's upload this. Alright, let's open the serial monitor. And whoa, look at that. It works. What if we want to increase the baud rate? Now what happens if we just do this? That's ugly. Of course, we have just messed up all the timing. Won't work. Alright, let's try again. Yay, it works at 900. Why didn't it work at? There you go. So that's how you can change your baud rate on the serial communication. Well, usually 19,200 is fine. I mean, I know, unless why would you need like the 115K just for debug statements. Now, this was a pretty plain demo wherein you are not really doing anything with the debug statement. If you want to actually see how we can really actually debug the variables or the values that we have in the program, just leave a comment down below, and I'll make sure that I'll have a demo of using an actual scenario where we can debug this. So until next time, see ya.